This video is for Chapter 6, Lesson 3, where we're going to be working with algebra, variables, and expressions. Your learning target today is to be able to find the value of expressions or number sentences using the order of operations. Please open your textbook to page 449 and get your materials ready and continue the video. So this is not in your textbook. So it's just an activity I'd like you to listen to and kind of follow along with. Jamie went trick-or-treating. She got 3 pieces of candy at each house she went to. So my question is, how many pieces of candy does she have if she went to 35 houses? So let's think about it. What would be our math? If I got 3 pieces of candy at every house, I would multiply it by 35. Rather than adding 35 times in a row with repeated addition. So 3 times 35, do our math over here on the side, we get 15, 9, 10. She would get 105 pieces of candy. So what would happen though if she went to 100 houses? Well, then it would be 3 times 100, which I can do easier in my head. We would say that she has 100 pieces of candy. 300 pieces of candy. So what pattern is happening here? How would we figure out how much candy she's getting? Let's say we're going to a new neighborhood and we don't know how many houses are there. Well, then we're going to use something called algebra, which simply means that we're going to use math with letters that represent mystery numbers. If we go to a new neighborhood, we won't know how many houses are there. So we could pretend that that is H, represents the number of houses that are there. And what are we going to do with H? Well, then we're going to make it 3 times whatever H is. Whether it's 1,000 or 52 or 17 houses, we'll just take 3 times whatever number of houses there are and we can find our answer. What we have right here is an algebraic expression. And today we're going to be using algebraic expressions in evaluating number sentences with them. How many of you remember this from everyday math back in 5th grade? Remember the in and out rule box? They said if we put a number in, the rule is take whatever you put in and multiply by 2 to get your out. So if we put 7 in, we would get 14 out. If we put 4 in, we'd get 8 out. If we put in 2, we would get 4. And if we put in 0, we'd get 0 out. So what would we do if we don't know that number? Well, today in our lesson we're going to talk about algebra and using variables. Using a variable simply allows us to say that we don't know a number. So we're going to represent it maybe like with a letter like n, that we don't know what the number is. So to evaluate it, we would say n times 2, and that will give us whatever our answer is. So algebra is a language of symbols including variables. And a variable is simply a symbol, and we almost always use a letter to represent another number. So the math meaning is of a variable, it is a symbol that represents a number. In its everyday meaning, the word variable means to change or vary. Like we might say variable winds, like the winds are going to be changing. They might be stronger in the morning and calmer in the afternoon and then get much stronger again in the evening when it gets dark out. That's variable. So an example of variables, most often in math we use x, we see a lot of y's, n, a lot of times a. Non-examples would be 3, 7, 22, -3, because those are actual numbers. So today we're going to be working with one-step expressions, meaning a lot of this work today we could do in our head. We would not even have to write them down. We can just do it mentally with mental math. But Today's lesson is getting you prepared for the heavy level expressions that you're going to solve in 7th grade. So, algebraic expressions, that just means a number sentence, contains at least one variable and at least one operation. So remember that the word math operation, there are 4 math operations that we have to keep track of. We can add, we can subtract, we can multiply, and we can divide. And the variable just means that we're going to use letters in our math to represent unknown numbers. So, for example here, any letter can be used as a variable. A lot of times we'll see n. So here this expression is n plus 2, which means that we have the variable. So it's an algebra expression. And we have an operation here. We're going to find the sum because we're adding. The letter x is used the most. It is the most popular variable. To avoid confusion with the symbol x, which means multiplication, there are other ways to show multiplication. A lot of times we can put a dot. In everyday math, we used to do 5, and we would kind of put that star sign. That would be another one from everyday math. Most commonly, though, now we're going to be seeing this dot, or we're going to see parentheses, or this letter. Right here, this is my favorite. This is true algebra, is when you have a number sitting next to a variable. Right in between there, it means multiply. And this is the big one. This is the one that you need to learn and be ready to use next year. This one, the other 3 are fine, but we prefer this one. The variables in your expressions then, we can be replaced with any number that we choose. Once the variables are replaced, then we can evaluate, which again means solve, the value of that algebraic expression. So let's take a look here. They said evaluate, which means solve. Let's write it up there so we remember. They want us to solve the expression 16 plus b. And then they're telling us that we're going to pretend that b is 25. So on your paper, I know that it's in the book, but I still want you to start practicing with me. We're going to write down the original expression first. Then we're going to replace the variable. So we're going to put 16 plus 25. And then using our order of operations, we know that there's only one operation to be done. So we're going to add them together. 6 plus 5 is 11, carry the 1. 2 plus 1 is 3 plus 1 is 4. So our answer is 41. Let's take a look at another one. Here they want us to evaluate or solve x minus y. And they tell us that x should be equal to 64 and let y equal 27. So we'll start by writing our expression x minus y. We'll substitute in our the amounts for each variable. 64 subtract 27. And this one I do need to stack up, but we can see our work over here has already been done for us. Our answer will be 37. Now, let's go ahead and evaluate 6x. Remember, 6x is the same thing as saying multiply. So then they also want us to pretend that the x then is 1/2. So 6x is what we would write down. Then we take the 6 and we're going to multiply it. We can put a dot by 1/2. So we know exactly what to do with these. We've been practicing these in chapter 4. 6 over 1 times 1 over 2. So we can simplify. I can divide them both by 2 and I get 3, and this becomes 1. So we get 3 over 1, so our answer is 3. Let's try a couple together. So evaluate each expression. If anytime we see A, we're going to put in 6. Anytime we see B, we'll put in 4. And every time we see a C, we're going to put in 1/3. So let's get started. We have A plus 8. So they've already written it down for us. So now we'll rewrite it though anyways. A plus 8 And now I'm going to go ahead and replace the a with 6 plus 8 equals 14. And again, I know these are very simple. We could do these in our head. We're learning our process so that when we get to the more difficult expressions in 7th grade, you'll do just fine. So the next one, a minus b, we're going to take and replace the a and make it 6, and replace b and put in 4, and 6 minus 4 is 2. This next one, they'd like us to take a times b. So a is 6 times b, which is 4, and you get 24. And over here we have 9c. Remember, that means 9 times c. So 9 times 1/3. So we treat it just like what we would with fractions. And we can divide by 3 and simplify ahead of time. And so we get 3 over 1, or 3. So now we're going to start adding in a little bit more each step. Take a look. They would like us to evaluate 5t plus 4. Now this is where we had to bring in that PEMDAS. Remember, parentheses, exponents, parentheses first, and then exponents, then multiplication and division in order from left to right, and then we can add or subtract in order from left to right. So let's start by rewriting it as 5t plus 4. And they said let t be 3. So we have 5, and a lot of times people put parentheses, 5 times 3 plus 4. And now we use our order of operations that we're going to multiply first, then we will add. So 5 times 3 is 15, plus 4, we rewrite it, bring it down, and now we add 15 plus 4 is 9. Let's take a look at C. They want us to evaluate 4x squared. And they said let x equal 1/8. So we'll start by rewriting it, 4x squared. So then we're going to replace the variable, 4 times 1/8 squared. So this looks kind of tricky. We have multiplication and we have exponents. So we have to do the exponents first, and then we'll get to multiply. So we're going to do 1/8 times 1/8, and that equals 1/64. So our next line will be 4 times 1/64. So we set it up over in fractions, and we can simplify. We can divide by 4. Goes in there once. 4 goes into 64 16 times. 16 times. So 1 times 1 is 1, and 1 times 16 is 16. So we get 1/16. So let's try this one. They want us to take 10a plus 7, and they want to evaluate it as if a is equal to 1/5. So we'll put in our 1/5, and in order to do that, we're going to do 10 over 1 times 1/5. And when we do that, we can simplify. 5 goes into 5 once, 5 goes into 10 twice, and 1 times 2 is 2, and 1 times 1 is 1, so our answer is 2. And then we'll add 2 at that, add 2 to 7, and we'll get 9. So let's try a couple here. They're saying evaluate each one, which means solve again, and D is equal to 12, and E will be 1/3. So let's do E first. 2D minus 5. So I'm going to rewrite it. 2D means multiply, so 2 times 12, subtract 5. Go in, and multiplication comes first, subtraction is second. So we'll take multiplication. 2 times 12 is 24, minus 5. We'll subtract, we get 19. So let's try F, 50 minus 3D. So we write down the 50, subtract, and this is going to be 3 times the 12. Set up our game plan. I see multiplication will come before subtraction using PEMDAS. So 3 times 12 is 36. And I rewrite the whole expression. Now I'll do 50 minus 36. So if I stack that up over here, I have to borrow. We get 14. So our last one, we have 9e squared. So rewrite it. We have 9 times, and we have 1/3 squared. So our exponents come first, then our multiplication. So we're going to take care of this first. So 1/3 times 1/3 is equal to 1/9. So we have 9 times 1/9. We can put the 9 over 1. Hold on, I'll clean that up, sorry. Over 1. And the 9 cancels the 9, because 9 times divided by 9 is 1. 9 divided by 9 is 1. So we have 1 over 1, or 1. So let's look at a story problem. They said Cahill is wrapping a gift for his brother's birthday. The box has side lengths that are half of a foot. Use the expression 6x s squared, where s represents the length of a side, to find the surface area of the box he's wrapping. So write your answer in square feet. So they took our 6x squared. Actually, we'll just talk it through up here. 6s squared. They took 6 times the 1/2 squared. When you find the square, remember that this over here tells you to take 1/2 times 1/2, which equals 1/4. And then we rewrite it as 6 times 1/4. So we put 6 over 1 and simplify. They could have simplified earlier. They did 6 times 1 is 6 over 4. And that is the same as 1 and 1/2. All right, so if you're having trouble, be sure to come and ask questions. And otherwise, find the practice assignment from the board or come and get it from me.